Today we are going to discuss the effect of conjugation on the position of UV band. In the last lecture we have discussed about the four shifts. Which are the four shifts? That is bathochromic shift, hypsochromic shift, hyperchromic shift and hypochromic shift. In this effect we have to analyze, that is on which quantity the effect is called as bathochromic shift. In bathochromic and hypsochromic shift we have to concentrate on absorption wavelength. In case of hyperchromic shift and hypochromic shift we have to concentrate on the term that is absorption intensity. Now we have to stress the effect of conjugation in case of a diene and a enone. Now in this lecture we have to first analyze what is meant by a diene and what is meant by a enone. Before going to this, we have observed that is the wavelength of absorption intensity increases or decreases and or depends on the factors like first is conjugation, second is steric effect and solvent polarity. Now one by one we will discuss these factors in case of only dienes. Okay, that is in last lecture up to this, wavelength of absorption or a absorption intensity. These factors depends upon, that is presence of exotherm, removal of chromophore, removal of solvent polarity and so on. What is the value of a lambda max? So let us start with the dienes. Dienes are of two types. Which are into two types? First is isolated dienes, and second is acyclic dienes. What is meant by isolated dienes? That is the compounds containing double bond followed by single bond, again double bond, again single bond and then double bond. The compound is known as a isolated diene. For example, 1,5-hexadiene. Okay, isolated diene example is, that is 1,5-hexadiene. What is the structure? See here, hexane means 6, 1, 2, 3, 4, 5 and 6. Okay, you have to count here the double bond is from for one position, 1, 2, 3, 4, 1, 2, 3, CH, 1, 2, CH. Okay, what is the position? 5, 1, 2, 3, 4 and 5. Okay, here 1, 2, 3, 4, 1, 2, 3, 4. Okay, here also 1, 2, 3, 4. This is the example of a 1,5-hexadiene. Okay, now simple example of diene is the CH2 double bond CH2. That is the ethylene. This ethylene absorbs the lambda max at a 175 nanometer. And if this conjugation is increased, here the absorption wavelength is also gets increased. That is, in case of 1,5-hexadiene, the value of this 1,5-hexadiene is about also a 178 nanometer. This is the value of a about, that is a 165 nanometer, but this is value is of about 178 nanometer. Okay. Now what is meant by enone? Okay. Enone means that is compounds containing carbonyl group and the carbon atom which is adjacent to carbonyl group. Likewise, this nature that is single bond, double bond, single bond, and then also single bond. Okay. Likewise here, if this type of link is present in the compound, okay, that is single bond. Here this carbon atom is called as alpha, this is called as beta. Okay. This is single bond, this is double bond. Single bond, this here also double bond. This type of if link is present in our given compound, at that time we have to call this as enone. Enone means that is the presence of a carbonyl group. Now simply the example of a diene is that here in the problem we have to identify only the dienes. Okay, that is familiar example of diene is 1,3-butadiene. 1,3-butadiene. Also in number of reactions like the last order reaction, we have to see this compound. What is the structure? See here 1,3-butadiene. Okay, 1, 2, 3, 4. This for butadiene means butane means butane. Butane means 4 carbons. Di means 2 double bonds here, and which position of 1, 2, and 3. That is 1 and 3 positions. Okay. That is structurally it may be represented as CH2, CH, CH2. Here also C double bond CH. How many carbon atoms are here? That is CH2. 1, 2, 3, 4. Here also one double bond. Therefore it is CH. Okay. This is the structural formula. If this formula is correct, just we have to count the valency of carbon is equal to 4. What is the carbon is here? 1, 2, 3, 4. Here also 1, 2, 3, 4. Here also 1, 2, 3, 4. Here also 1, 2, 3, 4. That is, this is the correct structure for the butadiene. In some of the examples, while solving the problems related to diene according to Woodward and Fischer formula, you have to keep in mind that is where is the structure of a 1,3-butadiene. Okay. Now we will see the rules for the conjugation. If it is changed, what is the graphical nature? Okay. See here. Absorption intensity A or epsilon here. Okay. And the ranges of the Leventhal here, that is from a value 200, 250, 300, 350. Here we have to take the examples of, see here, okay, these types of graphs. Now these types of graphs of which values, that is here how many peaks, and how many peaks. Okay, from the peaks we have to observe the compounds. Okay, now which are the compounds? See here, that is which position? Here count 1, 2, 3, 4 and 5. That is how many peaks are here? That is 2 and 4th position. Okay, therefore here peaks are observed at which positions? That is 2 and 4. Therefore you have to concentrate the structure of this is at, okay, this the structure is at 1, 2, 3, 4, 1, 2, 3, 4, 5. Here also 2 and here also a 4th position. Okay, this is the structure. 2 peaks. Now 3 peaks. That is the presence of 3 double bonds. Okay, like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 3, 4, 5 and 6 here. This type of. Okay, here the presence of 1, 2, 3, 4. Okay, 2, 4, 6 and 8. Okay, the structure is as follows. 1, 2, 3, 4, 5, 6, 7, 8. So here 2, 4, 6, 4, 2, 3, 4, 5, 6, 7 and 8. Okay. Here also this and here also this. Okay. This type of structures. That is, here from the examples and number of peaks, you have to observe that as the double bond conjugation, here double bond, single bond, double bond, double bond, single bond, double bond, single bond, double bond. As this number of double bond conjugation increases, number of peaks, that is the position of UV band. Which band? Here we have to consider, that is ultraviolet band is on increases. If now there is one problem, that is if this double bond conjugation is so increased or so longer, what happens? Okay, when double bond conjugation is increased about so longer, at that time what happens? It is bathochromic shift deepens and the band goes to a visible range. And the compound becomes a colored one. When we see the compound becomes a colored one, when the compounds containing double bond conjugation is so far, that is so longer, at that time bathochromic shift is deepens and the UV band goes to which range? That is visible range, and thus the compound is a colored one. For example, beta ion appears as a yellow, which contains 11 double bonds. Which contains how many double bonds? It is 11 double bonds. Due to that is the UV band goes to a visible region, and thus the beta ion which is appears as a yellow color. Okay. Now we will discuss about the Woodward's rule. See here. Now we have to discuss about Woodward's and Fischer's rules for the butadiene. Already we have seen the butadiene structure. Simply it is also called as a diene. The basic IUPAC name for butadiene is a 1,3-butadiene. Again, I will repeat the structure like this is the structure of a 1,3-butadiene. In this butadiene, according to the structure, we have to calculate the absorption wavelength appears to be at maximum wavelength with consideration of a experimental value. By using Woodward-Fischer rule, we have to calculate the experimental value using the Woodward-Fischer rule, and we have to compare it into a observed value. Okay, that is what is the value observed when the compound is butadiene is taken. Okay, before seeing this, we have to understand the number of dienes occurs in butadiene. In the first rule, there is only a parent diene of 3 types. First is a acyclic diene. You have to concentrate on this structure, that is 1,3-butadiene. Already any of the problem you have to concentrate only on a butadiene. Which butadiene? That is a 1,3-butadiene. 1,3-butadiene. Okay. Acyclic means what? That is open chain compound. Which compound do not possess a cyclic, but the arrangement of some single and double bond, which is a conjugation one. It is double bond, single bond, double bond. If this system is present, it is called as a acyclic. Okay. Now the cyclic. Cyclic is of 2 types. Okay. First is homocyclic and second is heterocyclic. Okay. Cyclic means homocyclic, which is an heterocyclic. Homocyclic and heterocyclic. Okay, this is a cyclic system. Generally, this is an example of a homocyclic. Benzene ring is only 1, but here the presence of a double bond and single bond are present in a only one benzene ring. Same benzene ring, if conjugation is occurs at that time, it is called as a homocyclic butadiene. And if it is a heterocyclic, what is the structure? Like this. That is 2 benzene rings, but the butadiene system is present is like this. First you have to name here 1, 2, 3, 4. Okay, this is the butadiene. Here this is the butadiene. What is the semi-cyclic? Semi means half in ring, half in out of ring. Okay, this is also a butadiene. Okay, see here 1, 2, 3 and 4. Okay, that is in any of case you have to just identify 1,3-butadiene. Okay, got it? That is, these are the types of the acyclic, cyclic and semi-cyclic. We have to just concentrate on acyclic and homocyclic and heterocyclic. Now what are the rules? See here. In acyclic diene, acyclic or heteroannular or heterocyclic diene, the basic value is, the basic parent value is, that is heterocyclic or acyclic means what? When there is in a compound, if we identify, the 1,3-butadiene structure, if it is present, the basic value is about 214 nanometer. In some books it is given as a 215 nanometer. Whatever we have to take the value, any of one thing, there is only a 1 nanometer difference in our final answer. Got it? Second is the homoannular or homocyclic diene. Homocyclic dienes, that is in a same benzene ring, when this structure is present and the diene is called as homocyclic. At that time you have to take the value as 253 nanometer. Okay. Now after this you have to identify the ring residue. This is the most important. Ring residue or alkyl groups. Alkyl groups. Okay. How to identify ring residue or alkyl groups? In a given butadiene structure, when we identify that when this butadiene structure of 1, 2, 3 and 4 carbon atoms, if attached to any of the bond or an alkyl group, you have to identify it as a 1, 2 and 3. If one alkyl group is present, for each alkyl group or each ring residue, you have to add 5 nanometer. For OR group, alkoxy group, you have to add plus 6 nanometer. Okay. Now the another rules are as follows. If it contains the halogens, each halogen add plus 5 nanometer. Okay. If the parent butadiene contains exocyclic double bond, you have to add it as 5 nanometer. If the parent butadiene contains a double bond conjugation, with extension, that is your parent butadiene here, also there is a conjugation of like this. See here, this is up to a butadiene. If there is a conjugation like this, if there is conjugation, external conjugation, it is called as. If this conjugation, how many times external conjugation here? 2 times. For each conjugation, you have to add 30 nanometer. Okay. Again, I will repeat it. That is for Cl and Br halogens, each halogen you have to add 5 nanometer. For exocyclic double bond, add 5 nanometer. Double bond extension conjugation to add 30 nanometer. Okay. For AO or CO or group, you have to add no nanometer, that is 0 nanometer. Okay. And last rule is that if the exocyclic double bond, present to one benzene ring, add 5 nanometer. If this exocyclic double bond is matches to 2 benzene rings, you have to add 10 nanometer. That is, each benzene ring you have to add 5 nanometer. Now we have to discuss, or we will discuss some problems related to Woodward's and Fischer rules according to these criteria. See here. Our first problem here. This is the structure. Okay. If you are given. See here. First problem you are given. Now in this problem we have to just watch the given structure and we have to identify the 1,3-butadiene. That is here from. Say it is 1, 2, 3 and 4. Just rule it as follows. We have to identify here, that is 1, 2, 3. That is here that. What is the structure? That is 1,3-butadiene. Our similar structure is like this in last video, and already we have seen this structure. Now according to rule, what is the solution? How to find out the lambda max for the given compound? First point is about basic value, basic parent value. Now see here, in this case, these two double bonds are present in two different benzene rings. That is, this compound is of structure of heteroannular ring. Heteroannular ring. Okay. Hetero means two different rings. Is it correct? Correct. That is, two double bonds are present in a conjugation, also present in two different rings. For that purpose, about the rules, we have to add here, that is 214 nanometers. Now the next point. What is the next point given to you? If there is a alkyl groups or a ring residue. After identifying this butadiene structure, you have to stress on the number of carbon atoms attached to a butadiene. Which are the carbon atoms? 1, 2, 3, 4. Except this structure, how many bonds are given out from the structure? That is, this is first ring residue, this is second ring residue, okay, this is third ring residue, at this position, okay, at this position and at this position, three positions are one ring residue, second ring residue, third ring residue, is about fourth ring residue, okay, that is 4 ring residues. Also it called as to be alkyl groups. Each ring residue you have to add 5 nanometer. For 4, you have to add it as 20. To multiply 5 into 4, that is equal to 20 nanometer. Now what is the remaining in this ring? Suppose this ring, if you draw here further, add is as a exocyclic. Before seeing this exocyclic, you don't know the exocyclic. Okay, exocyclic means that if we concentrate on the benzene ring, that is a cyclobenzene ring, okay, without presence of a double bond, each corner then contributes a double bond. 1, this is 2, this is 3rd, 4th, 5th and 6th. If outside of the benzene ring, if there is a presence of a double bond, at that time it is called as a exocyclic double bond. Exocyclic double bond. Now how many double bonds are here? 6 double bonds. Now we have to concentrate in our compound. In our compound, we say it is called as benzene ring first, benzene ring second. Okay. With respect to first ring, how many exocyclic double bonds are here? No one are here. But with respect of second ring of this point, this is a double bond. Okay, that's it. 1 exocyclic double bond. 1 exocyclic double bond. For 1 exocyclic double bond, what is the value? That is 5 into 1, that is equal to 5 nanometer. What is the remaining presence of a Cl, Br, O, COR, OR group? No, that is, this is the answer by taking the sum of these 3 values. Therefore, lambda max, simply you have to take the sum, that is lambda max is equal, what is the value? 214 plus 20 plus 5, that is equal to 230. That is, final value for this compound is equal to 239. Okay, again we understand all of you. If there is a problem, ask me and we will clear your doubt. Okay, we will take the another example. See here. Another example. See here. See here, this is the example of acyclic diene and this is an example of which diene? heteroannular or homoannular, or heterocyclic or homocyclic. Okay, just you have to identify first 1,3-butadiene. Okay, just consider on 2 double bonds. If the double bonds are conjugation with each other, okay, 1, 2, 3. That is, then we have to count the value as from here or here, whatever may be, 1, 2, 3, and 4. Okay, that is the structure of butadiene is as follows. Okay, this is a butadiene. But before writing the parent basic value, you have to concentrate on these 2 double bonds, whether the 2 double bonds are present in one ring or the another ring, or whether the 2 double bonds are present in both the rings. Here the 2 double bonds are present in only one benzene ring, that is this benzene ring is called as a homoannular ring. And for homoannular ring, what is the parent basic value? Therefore, parent basic value is equal to 253 nanometer according to our Woodward and Fischer formula. Okay, once we get the basic value, you have to identify second criteria. What is the second criteria? Is the presence of a alkyl group or ring residues. Here, alkyl groups or ring residue. Now, consider the positions of the butadienes. First is the first, which is the ring residue first. Second, no. Third, no. Fourth, this is and this is. Okay. Now, how many ring residues? 1, 2, and 3. Here 1, here 2, and here 3. That is 3 ring residues. That is 3 into how many? Value 5 is equal to 15 nanometer. Now, what is the remaining? If we see this ring of how many exocyclic double bond? This is the first exocyclic bond. And with respect to first ring, how many exocyclic double bond? There is no exocyclic double bond. With respect to second ring, exocyclic double bond equal to 1. How many? 1. Therefore, 1 into 5 equal to 5 nanometer. What is the remaining one? Again, we have to see the structure. First, this is of double bond. Of butadiene structure is same ring. Therefore, ring is called as homoannular base. Parent value is equal to 253. Again, one exocyclic double bond with respect to ring second. And again, the alkyl groups are 1, 2, and 3. Okay, up to 4 positions. Okay, 3 rings, so therefore 3 into 5, what is the total? Now we have to take the total. Lambda max is equal to 253 plus 50 plus 5, that is equal to 3, 273. That is lambda max is equal to 273 nanometer. That is, this is the final answer. Okay, what it? Now the second example. See here. In this second example, we have to calculate first the diene. What is the butadiene? Here 1, 2, 3, and 4. From here, 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 and here. Okay. This is the first carbon. Okay. This is of a open chain. That is a acyclic diene. Therefore, we have to write it as acyclic diene. Parent value, how much? That is equal to 240 nanometer. Okay. Now we have to concentrate on the ring residue. On fourth position, how many rings residue? 1, 2. For second, how many rings residue? 3. For fourth, how many residue? 4. That is, this is 1, this is 2, this is 3, and this is 4. That is, how many ring residues? That is 4 ring alkyl groups or ring residue equal to 4 into 5 is equal to 20 nanometer. What is the remaining? This structure is of open structure, therefore there is no presence of a exocyclic double bond, no presence of a conjugation. Therefore we have to stop here. We have to take the same, that is 240 plus 20, that is equal to 234 nanometer. Okay, therefore lambda max for this value is equal to 234 nanometer. In this way, we have to take the examples. Once you get the idea for observing and identifying beta, you must familiar with these examples.